If you try to melt dry ice, you're going to be pretty disappointed. For example, if I take this chunk of dry ice and blow heat on it, it kind of just disappears. If you look at a phase diagram for water and dry ice, you'll see that with both of them, if we start off in the frozen state, meaning solid at atmospheric pressure, and then I heat them up, for the water we'll cross this line, which means that the solid will turn to a liquid. But then as I continue to heat it up, it'll turn into a gas. But if we look at the CO2 phase diagram, we'll see that when you start with the solid CO2 at atmospheric pressure and then heat it up, it doesn't ever cross into the liquid area. It's too low on the diagram, meaning the pressure's too low. So that means if we just raise the pressure, then it will act like normal ice and melt into a liquid and then evaporate. Put it in the vise real quick. Right when the pressure hits about 5 atmospheres, then the dry ice will begin to melt into a liquid. Okay, in order to see what's going on, I'm going to be blowing dry air on this vial. This will keep the condensation from forming on the vial and blocking what we're trying to see. So you can see that as the pressure rises, the dry ice just melts into a liquid. That's so cool. It just resembles normal ice melting at this point. And we're left with a vial of liquid CO2. The liquid will quickly freeze again because when you release a pressurized gas, it gets colder. So the liquid quickly turns to a solid again because it gets colder when I release the pressure. But then if I pressurize it again by tightening the vise, it'll melt into a liquid again. Now here's the danger. Once the dry ice is melted, this vial won't just stop pressurizing to 5 atmospheres. If I let it keep pressurizing and it had the strength, it would go well beyond that. It would get up to around 60 atmospheres. Now this vial can't contain that pressure, so it'll inevitably explode. Whoa. That's why you should never put dry ice in a closed container.